Okay, so now we're going to get into a discussion of enthalpies, but this time we're going to talk about standard enthalpies of formation. Now, one of the things that I want to say here is that enthalpy is a state function. We made mention of that fact before. And therefore, when we talk about the change in enthalpy, we can, if it's possible, determine the change in enthalpy of a process or a reaction by simply taking the value of the enthalpy of the products and subtracting from that the enthalpy of the reactants. Now, in theory, that would be possible, excepting that in practice, it's not possible because it is impossible to know the absolute values of the enthalpy of products and reactants or any substance whatsoever, right? So even though that would be very nice and convenient, we cannot simply calculate the enthalpy change based on this equation right here. So what we have to do is, as stated here, before I move on, we don't know the absolute values. So therefore, what we have to do is use what is known as a relative scale. And the relative scale is based on what we call a standard state for a substance, right? So first we have to define what the standard state of a substance is in this context. And here's the definition right here. It is a state of the pure substance at 1 atmosphere pressure and the temperature of interest, which is usually 25 degrees Celsius. And let me just say this. Please do not confuse this particular standard state definition with standard temperature and pressure, right? Standard temperature and pressure is basically something that applies to gases. Remember, in the previous chapter, we were discussing gases and gas laws, and we talked about the fact that the molar volume of a gas under STP conditions is 22.4 liters. Well, that is different from what we're talking about here. Here we're talking about basically the standard state for a substance involved in any chemical reaction and how we can find the enthalpy change for that reaction based on those standards. So the standards that are adopted for this purpose would be that the standard pressure is 1 atmosphere and the standard temperature is 25 degrees Celsius or 298 Kelvin. All right. So based on these conditions here, if you measure the enthalpy change of a reaction under these conditions, under these standard conditions, then that is called the standard enthalpy change. And we symbolize that by using the symbol that you see here, where you have delta H, which of course represents a change in enthalpy, but you'll notice that there's a small O or 0, which is written as a subscript, or I should say a superscript beside it. That symbol indicates that the conditions for the reactions are standard, meaning, again, that the pressure, if there are any gases, is 1 atmosphere, and the temperature would be 25 degrees Celsius, right? So as stated there, the standard enthalpy change for the reaction is the enthalpy change in which the reactants and products are in their standard states, right? And then we have another definition that you need to be aware of, and this is where the relative scale comes in. The standard enthalpy of formation for a substance is the enthalpy change that occurs when 1 mole of a substance is formed from its component elements, again under standard conditions. So that symbol here represents the standard enthalpy of formation, right? Where you have, again, the O here as a superscript and a F here as a subscript, all right? Okay, so basically, based on these standards, we can determine, and actually there are tables that have been developed which shows you the enthalpy of formations of different substances. But before we get to the table, let me just kind of reiterate this particular definition here, right? So as we said before, the standard enthalpy of formation is the enthalpy of formation of 1 mole of a substance from its elements under the conditions that we talked about, the standard conditions, 1 atmosphere and 25 degrees Celsius. So just as an example, if we say that the standard enthalpy of formation of methanol is minus 238.7 kilojoules, what we're saying is that for this equation, where you have the elements that make up methanol, the carbon, the hydrogen, and the oxygen, if they react like this to form 1 mole of methanol, then the enthalpy change under standard conditions for that reaction is minus 238.7 kilojoules under the standard conditions, all right? So please note how this equation is written, right? This equation is written for the formation of 1 mole of, in this case, methanol from its elements, right? And you'll notice that we keep the coefficient here for the methanol as 1, and you balance everything else based on that, including the fact that you have 1/2 of a mole of oxygen indicated here, which is, of course, not usual. Normally, we try to have integers, but in this case here, we have to make sure that the oxygen count on both sides are the same, so therefore we need a half here, because we need to write the equation such that we end up with 1 mole of the product. And that is true for any substance. Basically, the enthalpy change under standard conditions is for the formation of 1 mole of that substance from its constituent elements in their standard states. All right? So therefore, as I said before, tables have been developed based on that definition of the enthalpy of formation under standard conditions for different substances. And therefore, we can get values of enthalpy of formation under standard conditions and treat them as absolute enthalpies so as to determine the enthalpy changes for reactions. All right? Well, before I move on to this question here, let me just go and show you where the tables are located. So this is the table here. Let me just show you where it's located. If you go to Files in Canvas, and then you scroll down, and then you get to Tables, and you click on that. And then where it says Thermodynamic Data, you click on that. And then you can download that table, and that will give you, that's the table that you'll be using. Now you'll notice that the table has 3 columns, right? You have the enthalpy of formation, which is what we need, the standard enthalpy of formation, and then you have free energy of formation and entropy. At this level, for Chem 1, we won't be using these 2 values, all right? That is for Chem 2. For those of you who have to do Chem 2, when you get to the chapter dealing with thermodynamics and spontaneity of reactions and so on, then you'll be using free energy and entropy. But for all purposes, we'll just be using enthalpy of formation, all right? So this is a table that you would use, and I'm going to show you, using one example, how to use a table to determine the enthalpy of a reaction, all right? Okay, so let me go back to the PowerPoint here, because there's a question that is being asked down here. And the question is, what is the enthalpy of formation of an element in the standard state, such as oxygen, right? And the hint to answering this question is that to write an equation like this, the reactants will be the same as a product. So in other words, let me start writing here. So in other words, in the case of oxygen, okay, this is not working. Let me do this. Okay, it's working now. So in other words, okay, where is this thing? Okay. In other words, O2 gas to form O2 gas, right? Question is, what is enthalpy of formation under standard conditions for this, for oxygen? And the answer is 0, right? Because there's no change, right? By definition, therefore, the enthalpy of formation of oxygen, and not only oxygen, but pretty much every other element would be 0. And that will be seen again in this table. Let me go back to the table that I just showed you. If you look at this table and look at all the elements and the elements that are existing in their standard states under the conditions that we talked about, such as aluminum. Look at here. Aluminum has an enthalpy of formation of 0. Arsenic, enthalpy of formation of 0. Barium, enthalpy of formation of 0. It doesn't matter which element. Calcium, 0. If it's an element by itself, not combined with any other substance, such as carbon, well, in this case of carbon, there are 2 forms indicated here. The one that has the 0 value would be the graphite, right? The diamond has a slightly higher value in terms of the enthalpy of formation. But pretty much for most other elements in their standard conditions, their enthalpy of formation is 0. For copper, it's 0. Let me just scroll down. For lead, it's 0. And let me scroll down some more. For oxygen, we talked about earlier, 0. And so on and so forth. So basically, for the most part, elements by themselves, not combined with anything, existing in nature under standard conditions, will have